Video we will just focus on autoencoder fitness. So the trajectory looks like we have a base folder as applied computer science project. Then we have the main repository Lenia EE combined. We have experiments folder, and in experiment folder we have autoencoder fitness. So autoencoder fitness has these files. um, we are using all frames with varying bottleneck. We are using every 10th frame with varying bottleneck and last 10 frames with varying bottleneck. So in all frames 36 bottleneck. The code is IPYNB. Then we have the output. Basically the output has generation best fitness and generation average fitness, and we have elites. So elites look like we have generation 1 elite, and it's generation 1 elite. Then we have generation 2 elite. There are little perturbations because of the mutation. Let's see generation 101. Okay, this is again random kernel, and this is the output. Let's try for 491. And okay, so you see the autoencoder is actually not performing well here, and that's why we are discarding autoencoders. Let's check 72. We cannot decide directly by looking at 36 bottleneck in all frames, right? Let's check for 72 bottleneck and all frames, which was actually performing well on the plots. So maybe we can check quickly. This is the output of GIF, and this is how the kernel looks like. While generation 1 kernel looks like this, which is again a random kernel, and this was the output. So this is there. Then we have 16 bottleneck all frames. So this is the output for generation 0, and this is the kernel. While generation 476 or 499 has this kind of output, and this kernel. Then we have 36 bottleneck every 10th frame. The output looks like this, and the kernel looks like this. Let's check random generation between. The output looks like this. So kernels are random in first generation also, and in the last generation also. These are not known kernels or handcrafted kernels, and the perturbations or mutation happens only 2% times. So 2 pixels at a time at most. So it's like this. The kernel looks like this, and the output looks like this. For 72. So all these results and outputs will be uploaded on Google Drive. So the original paper that we are building has all the results, all these results basically. So you can either reproduce, or you can try to play around with the code, or you can try to just view the results. So this was all for autoencoder part. So we have these many configurations, and for each configuration we have seen the outputs behavior, and as well as the kernel plot.